Hey, AP Physics students, how about a few hints regarding T3.2? That's page 85 and 86, number 55 and 60. Just a tiny bit of hint for number 55 because it's not that difficult of a question. They're asking really for the normal force. So if you look at the diagram, I'll place the diagram here for you to see. If you look at the diagram here, you have these three blocks. We want to know the normal force exerted on block number one. In order to analyze that, all you need to figure out is exactly how the floor is pushing back up. So suggestion, put a dot there for the box and draw the force vectors that are acting on it. That should help you determine what the force is acting on the box from the floor. Now the more crucial question, and that would be number 60. So we are pushing on this block or brick or something, and we're holding it on the wall. And so there are two questions. One, the first question is part A, what's the minimum force to keep it from sliding? Part B, I want the minimum force to actually make it start moving up the wall. Now, they seem like the same kind of question, but they have the following slight difference. This is equilibrium. Everything adds to zero, okay? There are how many forces? Well, you have to analyze it by a free body diagram. So at this point, even if you're doing this, watching this video at this moment, you should maybe click pause and draw the free body diagram so you can figure out what's going on. Now, the suggestion is certainly you've got gravity pulling down, okay? That's the weight vector, and we know that that's m times g. You also are, as you push up on this, trying to fight to push it upwards, and that is a component. That's this component right here. You could use trigonometry to figure out what that force is, lifting upward. And I'll just tell you that this is the unknown force we're solving for. If you wish to find this vector, couldn't this be the adjacent side of that angle? And this could be F times the cosine of theta. So you'll have an upward force of F cosine theta, a downward force of the weight. Now you're trying to push upward to see how much force you need to make this keep from falling. What else is helping to stop it from falling? That would be friction. So there is an upward force of F cosine theta. There is an upward force of friction. And there is a downward force of the weight. They must add up to zero. Now, if you look at all of these things, you are almost done. You just have to solve for the force, except for how do you find friction? Well, you remember the force of friction is mu times the normal force. They've given you the coefficient of friction, mu. Remember, the normal force is the perpendicular force. I'll say one more thing, and it's a trigonometry thing. Find the force, the normal force, by finding that component pushing into a wall. Hopefully those things have helped you. Good luck.